Well, good morning again, and welcome to Greenhouse Inspiration, Design, and Construction for Energy Efficiency. As I mentioned a moment ago, this is being sponsored by the Oklahoma Orchid Society. I'm Doug Needham. I'm, as I said, the immediate past president of Oklahoma Orchid Society, and I'm retired vice president of education from Longwood Gardens out in Pennsylvania, and former professor of floriculture at Oklahoma State University. It is wonderful to have you all here today. We are so pleased with the great attendance and interest in greenhouses, one of my favorite topics. So I'm going to start off with some questions, and I heard some of you talking a little bit. How many of you currently have a greenhouse? Raise your hand. Okay, I know you're working on it, so 3 of you currently. All right, and now, how many are thinking about building a greenhouse? Oh, we're going to get lots of hands with that one. Hence why you're here today. Absolutely. And then tell me, what are you most interested in growing in your greenhouse? Food, vegetables. What else?
We'll say orchids because...
You're going to say orchids. All right, that's good. Overwintering, some tropicals that normally, yeah, great. All right. So vegetables, orchids, overwintering tropicals. Seed starting. Yeah, that's a great use for it. Anything else you could plan on?
They look cool.
What is that?
They look cool.
They do look cool. Well, very good. Well, I'll share with you, here's how I got started. This was 1975, a much younger man. My father and I built our first greenhouse, and this was in Lafayette, Indiana, very, very cold part of the nation. And this was a 12-foot diameter, pretty unusual greenhouse, 12-foot. It was called the Solar Flare, and it was manufactured by Sturdy Built Manufacturing out in Oregon. And as you can see, it's built of redwood, has single-strength glass sidewalls, and a fiberglass reinforced plastic roof. It was all passive ventilation, so there were louvers in the door that's back here on this side where you can't see, and then the dome would open based on how warm it got inside, and just passively air would then flow through it. Well, after not too long a time, we discovered that was not quite enough. And so we did put a powered attic fan up in that dome that would help push the air out, especially on those hot, humid summers in Indiana. We needed to get that moving. It was heated originally by forced air gas unit heater. And I've tried to remember what my dad said about how much it increased our gas bill when this was installed. And now I can't remember the exact figure, but I'm sure in today's dollars it would be horribly substantial. It was not energy efficient at all. As you can imagine, single strength glass walls, thin fiberglass reinforced plastic roof, and just redwood panels around the perimeter base. We did line that with styrofoam to try and help, but still very, very energy efficient. So wonderful first greenhouse, but I learned a lot about what I wanted in my retirement greenhouse. So here's what I have now. My wife and I built this in 2017 when we retired, built our retirement home with the glass house attached. And so what we're going to talk about today is what inspired me as I was designing this glass house, and how did I make it as energy efficient as possible, because I did not want to repeat those mistakes of 1975. So let's take a look at some inspiration from around the world. We'll start off with Victorian style. And of course, many of us think of the Palm House at Kew. So at Royal Botanic Gardens in London, this is the Kew Palm House. It was built in 1844 through 1848, and it was the first large-scale use of wrought iron I-beams for the construction. Notice the shape of it. the architects were inspired by shipbuilding, and they imagined turning the ship's hull upside down. So now if you look at that, you can probably see, oh, it does kind of look like a ship's hull turned right side up. And so by doing that, it enabled the roof to span nearly 50 feet between the columns. So at that time, that was a huge span to go between columns. And the curvilinear shape of it actually maximized the light that was penetrating into the glass house. So just a spectacular structure that's still there today to enjoy. Also at Kew is the temperate house. Look at that gorgeous structure. And that is the world's largest surviving Victorian glass house, also at Kew Gardens. It was completed in 1862, expanded in 1899, and fully restored in 2018. So beautifully restored structure to see over at Kew Gardens. Oh, look at this one. Isn't that odd? Would you believe that originally this was a personal glass house? It was the personal house of John Kibble, and he lived in Coalport, Scotland, and he built this, or excuse me, in 1871, he signed an agreement to give his glass house to the Glasgow Botanic Garden. And so they dismantled it from his home, his estate, and rebuilt it at Glasgow Botanic Garden. And so it's the Kibble Palace greenhouse. It's a little over 23,000 square feet. It's about 23.5 thousand square feet. And it was fully restored in 2006. So again, this is one that if you ever go over to England, you can, or into Scotland, you can go see this. And then look at that. What a spectacular palm house. Just that classic style. In fact, this palm house at University of Copenhagen was inspired by the Great Pavilion at the World Exhibition in 1851 in London. Some of you may remember seeing or hearing about that, or maybe you watched the movie about Queen Victoria and how Prince Albert envisioned this glass house for the exhibition. So that was the inspiration of this glass house at University of Copenhagen. Built in 1872 to 1874, cast iron and glass. Quite a spectacular house. And then coming across the pond over to the U.S., the New York Botanic Garden. Well, that's kind of a similar look to it, doesn't it? And yes, it's often called New York's Crystal Palace because it too was inspired by Joseph Paxton's Crystal Palace that was built in London. This is the Enid A. Haupt Conservatory at New York Botanic Garden in the Bronx. And it was built in 1902. And it was built by probably what was the preeminent greenhouse builder in the U.S. at the time, Lord and Burnham. How many of you remember Lord and Burnham greenhouses? No? Oh my goodness. As a teenager, I drooled over Lord and Burnham catalogs, dreaming of someday having a Lord and Burnham glass house. Well, Lord and Burnham is no longer in business, so that didn't happen. But anyway, this was originally built of limestone, cast iron, steel, bald cypress, and glass. Isn't that something? Significantly restored in 1997. So beautiful, beautiful Victorian glass house in New York. So some of the characteristics of Victorian design, and these pictures will change to emphasize some of them. Massive, massive curved glass palm domes. Ornate support columns and spandrels. That's that fancy ironwork at the top of the columns. Ornate ridge cresting, you may have seen there, and finials. Ornate spiral staircases up to canopy walkways. Ornate benches. Ornate vent levers. Ornate heating grates. What's the key word in that? Ornate, yeah. Everything about the Victorian is all this beautiful ornate ironwork. Just spectacular structures. Well, let's move on to neoclassical then. So this is the Royal Botanic Garden, Edinburgh, temperate palm house. Different looking in style, isn't it? Notice the stone columns and the large Palladian windows. This is styled after what's called an orangery. And an orangery was built to overwinter and grow citrus, hence the word orangery. Okay, so this was built in 1858, and it just is a beautiful structure that is there today for you to enjoy if you go to the Royal Botanic Garden, Edinburgh. This one is so interesting, so different, isn't it? This is a fernery, so it's a fern house, and it was built during the height of the Victorian fern craze when they were fascinated with ferns. And this house was built in early 1870s, and it's made of schist rubble, lime mortar, and then iron hoops and glass is the structure. And because it's for ferns, notice how much of it is wall, and it's actually built into the east wall of that hillside. Beautiful structure, and so fascinating to walk in and just be surrounded by ferns. It was completely restored and reopened to the public in 2009. So beautiful, beautiful house to see there at the Royal Botanic Garden, Edinburgh, Benmore. Well, let's come back over to the U.S. then, where I was. This is Longwood Gardens Conservatory Complex. Why do we use the word complex? Because it covers 4 acres in glass. It's a big glass house. So it's many glass houses. The original, which is there at the front, is the orangery. Look familiar? Big columns, big Palladian windows. So this was built opened by Pierre and Alice DuPont in 1921. And glass houses were then added in the 1960s and 1970s to where its current footprint is about 4 acres. Currently, Longwood is completing the West Conservatory, a brand new conservatory for the 21st century. It opens this fall and adds another 32,000 square feet of growing space under glass. Down in New Orleans, this is such an interesting glass house because it has its roots in the Great Depression. This glass house was a project of the WPA, the Works Project Administration, and it's one of the only remaining examples of a public garden work from the WPA time period and the Art Deco period. Notice its inspiration, neoclassical Greek and Roman architecture. So, some of the characteristics. Grandeur of scale, that's Longwood's orangery indoors. Symmetry. Simplicity of the geometric form. Dramatic columns with capitals. That's the East Conservatory at Longwood. Balustrade along roof edges. And, of course, Palladian windows are classic. All right, let's look at geodesic domes. Have you been to Missouri, to the Missouri Botanic Garden? This is the climatron. This was the first geodesic dome to be built specifically as a conservatory. It opened to the public in 1960, and it has no interior support, nothing. No columns, no interior support, all open space. That's the beauty of Buckminster Fuller's design of a geodesic dome. Climatron encompasses 24,000 square feet. It was extensively renovated in 1988 through 1990, replacing the deteriorated plexiglass that used to be its covering and replaced it with low emissivity insulated glass. Have you ever heard of that? Mm-hmm. You've heard of it. What does low emissivity mean to you? What's that mean when you talk about low emissivity glass?
It reflects the heat off of it.
Air does not go through it, but what it's referencing is, yes, it reflects the solar radiation off, so it limits solar heat gain, but it also reflects interior heat back. And so you don't have as great a heat loss through insulated glass. So this is one of the early uses. That's one of those pieces we're going to talk quite a bit about in energy efficiency. Oh, and look at these. Are these spectacular? Oh my goodness. This is the Eden Project down in Cornwall in England. And these are geodesic domes that are inspired by nature. They look anything that you've seen before?
Yeah, I think they have a zip line that goes over those.
I didn't see that when I was there. Do they look like soap bubbles? They're inspired. The architect was inspired by soap bubbles. And so these are two-layer steel space frame of hexagons and pentagons and triangles that's covered with a double layer of ethylene tetrafluoroethylene copolymer, sometimes just called Teflon film. And that's the beauty of it, is that those double layers are inflated with air. The Teflon film, as you think about Teflon cookware, is very slick, so dust doesn't stick to it, dirt doesn't stick to it, slides off, and it has extremely long life. So it doesn't yellow as other greenhouse plastics. It doesn't get brittle as other greenhouse plastics. It's UV resistant, and it has a very long life of about 30 years. Yeah. It is abbreviated ETFE, ethylene tetrafluoroethylene copolymer, sometimes just called Teflon film. So some characteristics: spherical space frame, geodesic polyhedrons composed of triangles, pentagons, hexagons, self-supporting, and inspired by nature. All right, the last group then, industrial modern. Oh, look at that. Isn't that spectacular? This is the Royal Horticultural Society Garden Wisley's glasshouse, and that's in Surrey, UK. It was opened by Queen Elizabeth II in 2007, so not very old, just coming up soon on its 20th anniversary. It's nearly 120,000 square feet. Massive house, mainly curved, tempered glass to maximize light transmission and thermal efficiency. And this particular shot, you may notice that the shade curtains on the inside are lowered. And then we come close to home. This one looks familiar to all of us, I bet. So this is the Myriad Gardens Crystal Bridge Conservatory right here in Oklahoma City. And it was designed by renowned architect I.M. Pye, commissioned in 1964 by our city leaders and our oil and gas pioneer, Dean McGee, to create a revitalization plan for downtown Oklahoma City. And so from 1977 to 1981, the garden's infrastructure was built, including the base to hold this cylindrical plant conservatory. And then the Crystal Bridge opened in 1988, and as probably many of you know, it was fully restored in 2022. So beautiful, beautiful house in downtown Oklahoma City. Well, let's go halfway around the world. This is Kaseki no Hoshi in Japan. And Kaseki no Hoshi translates as Miracle Planet Museum of Plants. And it's a spectacular design. It's the largest glass house in Japan, designed by Tado Ando and built of concrete, steel, and glass, covering about 72,000 square feet, and it opened in 2000. Just a beautiful, beautiful facility. And oh my goodness, look at this one. Actually, it's several. This is Shanghai Chengchen Botanic Garden, conservatories, plural. There's 3 of them, and they were built between 2009 and 2011. 3 massive aluminum alloy and insulated glass conservatories. The inspiration? Playful dragons coming up out of the land. So there's 3 humps of the dragon's back. And then we'll slip up to Canada, Niagara Park's Botanic Garden Butterfly Conservatory. So they built this specifically to showcase butterflies. It's full of gorgeous pollinator plants and other plants, but it's primarily for butterflies. It was built in 1996. It's 11,000 square foot glass domed conservatory, passive solar energy, natural thermocycling and ventilation, meaning that they're moving the air underground to temper it and bring it back up, evaporative cooling and thermal storage so that that heat can be stored underground and then released at night. So tremendous amount of energy efficiency was built into this in 1996. So that was quite significant. And the performance exceeded all of the design expectations. And now the last one, truly a house for the 21st century. This is Royal Botanic Garden Kew again. This is the Davies Alpine House, designed specifically for alpine plants to recreate the dry, cool, windy conditions that alpine plants need to thrive. It opened in 2006, and the stack effect of these two sloping panels creates a chimney stack, so the air naturally moves under those and out the top, creating this wind going through it. Below ground, air is cooled as it passes through a concrete labyrinth underground, and it's all covered in low iron glass, allowing 90% of the light to pass through. Truly a glass house for the 21st century. Isn't that spectacular? So industrial modern, vast open spaces, sometimes organic in form, as we saw at the Shenzhen Botanic Garden. Little interior support needed. Lightweight, energy-conserving materials. Elevated canopy walkways, that's the Crystal Bridge. And energy-efficient systems. So using insulated glass, using thermal screening, using passive ventilation, very, very energy efficient. So this is what I looked to as I was dreaming for the past 40 plus years about my second greenhouse that I would get to build someday. I was trying to learn as much as I could about energy efficiency and looking to these great conservatories from around the world for inspiration on design. So here's, of course, what I built. This is a 12-foot by 60-foot glass house. It was built by Solar Innovations out of Pine Grove, Pennsylvania. And as you watch this flyover, think about what design styles do you think inspired it? Oh, you noticed that. Yeah, notice the ridge cresting and the finial up there at the tip of it. And yes, inside there's spandrels. No structural need for it, but they're just so pretty. So yes, definitely Victorian inspired. We're going to talk about that. Perfect question. So some design build objectives. I really wanted to make sure I was creating something that was aesthetically attractive. And for my style, I love antiques. Victorian was what I wanted to have as inspiration. You notice the spandrels right there that I mentioned. Very Victorian to have that. Low maintenance. Hey, I'm retired. I don't want to be having to work too hard. I just want to be playing out there every morning. And easy access in the winter. If you remember that 1975 greenhouse, it wasn't connected to the home. So it was really cold to hurry out there in the winter, and there was no way you could bring plants back into the house because it was too cold. So I wanted to make sure it was connected to the house. So this is connected to our home. And I wanted to provide dual production zones because I got bit by the orchid bug when I was a teenager. Now, I've never recovered. So I wanted to be sure that I could grow cool-loving orchids as well as warm-loving orchids. So this section is the warm, and then right here you can see a little conservatory section where my wife and I love to have lunch and sit out in the warm greenhouse or entertain friends. And then through that door right there is the cool house. And so it provides those dual areas for growing orchids. And then the energy component of it. I wanted to make sure that it was sustainably designed and that it incorporated as much energy efficient systems and conserving materials as possible. So it is heat retentive in the winter, because yes, we are cold. It's only 25 out there today. I want to make sure it was heat retentive, but even as important, if not more important, that it was heat reflective, because we get really, really hot with high solar radiation in the summer, and minimal carbon input. I did not want to be expending lots of carbon to make sure that this greenhouse was operational. So we're going to talk about how I did that. Design parameters. I won't go all through these, but I want you, the main purpose of this slide is so that you think about where you're going to build your greenhouse, what kind of climate. So this is Stillwater, but not all of you, probably not many of you are from Stillwater. Where are you, and what are those typical rainfall, typical temperature, typical wind, etc. And then, based on what you're going to grow, so many of you said vegetables, you said you're going to overwinter tropicals, start seeds, that sort of thing. So think about what kind of temperatures do you need to do that. You may not need to be as warm as my warm house is for growing orchids, or as cool as the cool house is for growing cool orchids. But you need to know that, so then you can calculate what your system design is. What's going to be the lift? That means how much heat is it going to take to get to that indoor temperature that you need in the winter? And how much drop, how much cooling is it going to take to bring down the indoor temperature from a hot, hot summer day? So those are the pieces you need to think about. And so the system design was 45 degrees of lift from a geothermal hydronic radiant concrete floor. We're going to look at that. 62 degrees of lift from that, plus an emergency space heater if needed. 10-degree drop from evaporative cooling, and a 20-degree drop from a geothermal fan coil, plus the radiant floor. We'll take a look at all of these and how they work. Your question about orientation is spot on, because that's what you want to think about before ever deciding on where you're going to build that greenhouse, is you want to make sure, for us here in the southern part of the U.S., below 40 north, greenhouses should be on a north-south axis. So I twisted this around, north is up, and so you can see it is on a north-south axis, and it connects here on the north wall to our home. And that's what you want to do. Because we're in the southern part of the U.S., we want the sun to be passing over the length of the house. But if you lived up north, Michigan, Minnesota, so forth, then they orient them east-west, because the angle of the sun is so much lower in the winter that they need to maximize the sunlight and have the sun go over the length of the greenhouse. Any questions on that? No. All right, let's look at some base wall options. And I'm going to start with the least efficient and go to the most efficient. And so you can see this one's got a red around it. So this is probably not what you want to do, but it's very common. 4-inch thick concrete or 4-inch thick concrete block. U values of 0.78 and 0.64. That refers to how readily heat passes through that, okay? You could increase, and that's often done, to 8 inches, 8 inches of concrete, or an 8-inch concrete block, and that's a little improvement, 0.58 to 0.51, but look at this, 8-inch omni block, 0.05. That's what this is. This is omni block. And so it's a concrete block that has 2 channels in it. This is the outside panel, and this just happened to be broken. It wouldn't normally be that way. And then these are the inside pieces, and they keep going as you keep going down the wall. So the whole thing has these larger or chunkier pieces, and then these are on the outside. And that's how it's achieving, because there's not a clear direct path for heat to be transferred through it. So tremendously energy efficient. I wanted to take it as far as possible, so that was also covered with a 3/4 inch, what's called Dow sturdy R insulation, and that dropped it to 0.04. So it has a U value of 0.04. I did not want to be losing any heat, any more heat than absolutely necessary through the base wall of the greenhouse. And there you can see the construction as the base wall was going up. You can see all those pieces of foam in there, and then the sturdy R going on, and eventually the brick.
Question?
Yes.
What's the real world difference between .05 and .4?
Probably not huge, probably not, but it was also very easy to have that little bit of extra put on there. But would I have noticed it not being there? Probably not. Yeah.
What's the cost also just being?
And the cost is so minimal to put that on. Mhm. Oh, that's a great question. You know, it's been what now, 6 years? I don't remember that. The wall is about here. Yeah.
And then the concrete, anything special with concrete, you can talk about that?
Yep. Yeah, I cannot recall how high a base wall. If I had brought the drawings, we could have looked.
How thick is the glass, the wall glass?
Oh, we're going to talk about that, Zach. That's coming up as well. Great questions. All right, structural framing options. Well, certainly you could build a house out of wood, out of steel, aluminum, are some of the most common. Now, this lady up front, she's going to build one out of a school bus. Isn't that interesting? Great way to recycle an old school bus. Aluminum, it was the choice I went with because it's strong, it's relatively lightweight, it's corrosion resistant, so I'm not going to have to worry about it rusting over time, or am I going to have to worry about it rotting as it would if it were made of wood. And so this 12 by 60 is custom designed by Solar Innovations of thermally broken extruded aluminum frame. So thermally broken, again, means that heat cannot find a direct channel to the outside through that metal. Warm house is 36 by 12 by 12 high, so just a little over 4,000 cubic foot of airspace, 432 square feet of growing space. Cool house, 24 by 12 by 12, so just about 2,700 cubic feet of volume of air, and just under 300 square feet of growing space. Well, here's some glazing options that you can think about. And over on the left, we have, at the top is a polycarbonate corrugated panel, and I've got these on the table you're welcome to look at afterwards and inspect them. The one below it is a corrugated acrylic plastic. And then over here to the right of those are multi-wall polycarbonate plastics. So the top one's a twin wall, I think, and then a triple wall. But notice what happens over time. Look how yellow. So that bottom piece is actually off a greenhouse that was exposed to ultraviolet and hail. And so if you flip it over when you come up, you'll see there's a hole in it from where the hail hit it. So it becomes brittle and yellow over time. Those are some of the challenges. Yes, they're certainly less expensive, but I didn't want to have to be worrying about yellowing, and I didn't want to have to be worrying about hail. So I looked at low emissivity glass, looking at what was used there at the Shenzhen Botanic Garden in Shanghai. This is the low emissivity glass from Solar Innovations. The one on the left is low E 180, middle one low E 272, the one on the right low E 366. And so you can see they get progressively darker as we go from 180 to 366. We'll take a look at that here in just a moment. So let's do a little analysis on these glazing options and see, okay, if we want to be as energy efficient as possible, what do we need to be thinking about? And again, we got the red, yellow, and the green. So up at the top, your corrugated panels, the polyethylene film. Many of you may have seen or have had a greenhouse that had polyethylene film just stretched over hoops. That's certainly a way to make a greenhouse. Or single strength glass, as I had there in 1975. Heat loss, 1.2 to 1.13 for glass. That's a high heat loss. Didn't find any solar heat gain coefficients on the top two, but glass is about 0.85. Ooh, that'd be a little hot. And the light transmission's great. So you've got 90% with the corrugated polycarbonate or acrylic, just a tiny bit less through the polyethylene, and you're maybe 12% less on the single pane glass. So good high light transmission, that's great. I didn't want to have to put up lights in the greenhouse, not when we have beautiful sunlight in Oklahoma, and I didn't want to waste electricity to have to light the greenhouse, so light transmission was very important, but I didn't want to have this high heat gain. So let's look at the next category. You could do a double layer of polyethylene film and inflate it with air. That's one of the most common on hoop houses, and that gets a little better at 0.67, so you've almost dropped the U value in half. Solar heat gain is down to 0.79, 76% transmission. Or you could go with an 8 millimeter or even a twin wall or a 10 millimeter triple wall polycarbonate, these types that are shown right here. And you see that we start getting a little better. We're down to 0.58 to 0.44 for the triple wall on the U value. Solar heat gain coefficients, a little better. We're down to 0.74. Light transmission, we're getting down into the 80 or 72%. That's starting to drop a little low with the triple wall, but it depends on what you're growing. If you're growing lower light plants, that 72 will work great, and you won't have to worry about shade cloth. Well, you already know where I went. Low emissivity glass. So the choices were the low E180, 272, or 366. The company recommended 366 for Oklahoma, but I was concerned. You saw how much darker the 366 was. I was concerned that it might not be enough light in the winter, and I did not want to have to put up lights in the greenhouse. So I opted for the 180 and the 272, and look at these savings. U value of 0.26 and 0.25. Solar heat gain coefficient 0.64 and 0.41. We're almost half of what that single strength glass was back in the house of 1975 we had. And the light level, 79%, so still good high light levels, 72% on the 272. And what does that mean? I don't have to mess with shade cloth. Again, I'm retired. I didn't want to be pulling shade cloth, and especially having it snag on that ridge cresting. Oh, can you imagine how difficult it'd be to get shade cloth up there? Yes?
In the wintertime, the sun's further away from the earth than it is in summertime. Is that considered?
It is. Boy, did you know I was going to talk about that? That's a great question. So the question was, did you consider about the sun's angle in the winter and how in the winter it's much lower? Yes. So in the winter, we are going to get more sun coming in those sidewalls. It's the sidewalls that are 180. So I used the lighter one on the sidewalls, and I used 272 on the roof. Because in the summer, the sun's at a much higher angle, so more of it's going to be coming through the roof, and therefore more of that heat would be reflected by the 272. So that was how I decided the two types of glass to use. And so on the low E180, it is 2 layers, and you can look at these samples when you come up. This is how thick they are. It's 1 inch thick, 2 layers of glass, and it's sealed with, it has argon gas inside. That helps with its energy efficiency. And on the walls, it's tempered glass with a neat coating. A neat coating helps it resist dirt and debris, so it'll wash off with the rain. And tempered glass on the interior light. On the roof, I was concerned about hail, because we do get hail in Oklahoma, don't we? And sometimes very large hail. And I was concerned about that hail punching right through the glass. And so the outside, the exterior light is tempered, but the interior light is annealed laminated glass. So if we had really big hail hit that, and if it were to break through the outer layer of tempered glass, it would then hit that laminated glass. It would have lost considerable energy breaking through that first layer. I don't think we would physically break through and lose what's called losing the envelope, losing the environment from the greenhouse. I think it would stop it. We thankfully haven't tested it with any big hail yet, and I hope we never do, but we have had some small hail, and of course, did nothing to it.
Question.
Yes?
What did this do with your homeowner's policy?
It does not affect, I mean, in terms of, because it's a glass house, no. No.
Impact on that?
No.
Okay. I like that answer.
It's a great question. I wondered, but nope. all they were concerned about was just that it's an extension of the home. Yeah. So this is showing the spectral radiation, and for plants we always talk about photosynthetically active radiation because it's between 400 nanometers and 700 nanometers that plants see and use. We see outside that range, and so when we talk about light as humans, we think of light that's even below or above, but plants are seeing primarily this 400 to 700. So here you can see the low E180, very little difference from clear glass, just clipping a little bit up here in the far red, or infrared far red region. But then the 272, which is this line right here, that blue line, you can see it has brought it down, and so you're clipping that infrared and some of that far red. Any questions on the low emissivity glass?
In the end, right, you have not had to make any adjustments to lighting
No,
or shading?
no, that's right.
I expect
That's a great question, Neil. No, I have not done any shading in the summer, and I've not made any adjustments in lighting. There's only decorative lighting inside the greenhouse. We built it in 2017. Mm-hmm. So the foundation and heating is unusual for a greenhouse, and it's not terribly common in this part of the U.S. for homes. It's more typical up in northern U.S., and it's hot water hydronic heat. And so hot water flows through these plastic tubes that are now buried in the concrete floor. And in the summer, I can push chilled water through that. So I can actually chill the concrete to help further cool the greenhouse if needed. But again, remember I said I wanted to be minimal carbon input. So what's powering this? Geothermal. So 2 geothermal furnaces that have an output of 50,000 BTUs per hour, and there are 8 250-foot deep geothermal wells that are out in the front of our home. It's the prairie, right? They have a prairie, restored prairie. And so in the winter, it produces hot water at 105 to 135 degrees, and that's modulated based on outdoor temperature. Because if it's a mild winter day of 45, that water doesn't need to be nearly as hot as if it's a 15-degree day outdoors. And then in the summer, 43 to 48 degree chilled water for cooling. And this system is taking care of our home as well as the glass house. So that's part of why it's 50,000.
So in 2017, how much is something cost?
That's a great question. And on average, as you're thinking about building a greenhouse, you can expect to spend between $200 and $300 per square foot. Now that may have gone up now that we are in 2024 and building materials went up significantly during the pandemic. So it may be a little higher than that, but that was a traditional for that time period of 2017, somewhere between $200 and $300 per square foot.
Is that just for the glass part or the foundation
That's everything. That's everything. So when you're planning your greenhouse, you can be thinking, all right, based on this, how big I build this, it's going to be between $200 and $300 per square foot for the structure, the foundation, the heating systems, the cooling systems, so forth. Okay. There, you see there's styrofoam under those tubes, so that helps to prevent heat or transfer down into the ground. Yes?
Does the price include the geothermal?
So, yes, it would. And it would certainly put it toward that upper end. But again, it's being shared as part of our home system. Yeah, great question. And then, okay, yeah, so that helps prevent the transfer of heat. And so you get additional, if needed, and we'll look at when that was needed, supplementary heat from just a little electric space heater, if needed.
Question.
Yes?
How thick is the floor?
Oh, wow. That's a great question, Zach. I don't know how thick the floor is. I suspect it's whatever is a standard concrete floor foundation for a home.
Is there a certain height above the water lines for the geothermal?
I don't think so, because those water lines are heating the concrete, and then it's the concrete that's radiating that into the space. So I don't think that that part's critical as to what the depth is above the
Do you think it would radiate
tubing.
faster with a thinner overlay?
It would, let's look at it this way. Certainly the thicker the concrete, the longer it would take to bring that slab up to temperature is a very good point to make. If the thinner it is, the faster it's going to come up to temperature, or down if we're chilling it. Yeah. So the ventilation and cooling is passive ventilation. So passive, that's what you want to use as much as you can because it's not using any electricity. It's just cool coming in through the side vents and hot escaping out the ridge vents. There's horizontal airflow above and below. So above the benches, they're called horizontal airflow fans. The theory is treat air like a fluid, treat it like water, and if you get it flowing as a fluid, it will keep flowing in that direction. So you always mount your horizontal airflow fans so that one side is pointing south, for example, and the other side is pointing north, creating a flowing loop of air inside the house. And then I put fans under the benches as well because orchids are plants, they're epiphytes, they love air. They need air as much as they need water. So I wanted to increase that airflow a little bit. There's 3 Champion Essic Air N45S evaporative coolers, and I meant to give you handouts so you wouldn't have to be worrying about too many notes. I apologize, I didn't get those passed out right away. So if you'll send those back, then you'll have some of this handy for you. And they're capable of 3,432 cubic feet of air. So that's why you had to calculate what's the cubic footage air capacity of the greenhouse, and then how much air exchanges you're going to use. And the water pumps can either be on or off. I like to be able to control that so that if it's very humid outside, there's not going to be any evaporative cooling, so no need to be pumping water through them. And I also don't like them to be wet every night, and so I can program them to shut the water off as it goes into night. The hydronic concrete floor, I can chill it in both houses. I typically only do it in the cool house, and then specific to the cool house for what's called active summer cooling, you might even think of it as air conditioning. There's a 2.5-ton Envirotech fan coil that's connected to the geothermal chilled water as well. And so I use that on hot, humid days in Oklahoma, and specifically at night in the summer to pull the temperature down.
On your evaporative coolers and the system in general, does it produce
Condensation?
water from the
It does. Look at how wet the floor is, and that's not because I was watering. That's condensation because that concrete's cold and the air is so humid.
Can you capture that water?
You could, because it is just condensate, and so you certainly could. Yeah, I did not do that in the design. Pardon?
Would you put a drain now? You know, in retrospect, knowing that how much water is collected from the evaporator on the floor.
Would I collect it?
Would you collect it or try and get it out of the way, or does it
Oh.
sort of, you know, does it cause a hazard?
No, it doesn't. There's a drain right here, and so it's flowing to that drain. Yeah, the warm house has 2 drains. The cool house has 1. Yeah, so it does have drains. Question? Oh, just stretching. Yes.
How would you prevent condensation in the glass?
So I have very little condensation on the glass. Typically, the only time I see that is in the winter, if the cool house is very cool and the warm house is very warm, that separation panel between the two, they fog up. Yeah. But otherwise, I don't get much condensation on the glass. And I think it's because it is that 1-inch thick insulated glass. So even in the winter, the glass itself on the inside is not cold. It's cool, but it's not cold. Great question, Stephanie. Mm-hmm. You could, because it's condensate, it's essentially pure water. Yeah, yeah. But yeah, you could capture it and reuse it if you wanted. Good questions. But I did want to include a little piece about humidification. And so that's what it sounds like when the fogger is running. Kind of loud. Thankfully it doesn't run terribly often. And it's back here, you can see pushing out fog. So there's 2 Jaybird Aquafog Hydro SS700s, one in the warm house, one in the cool house. And again, this is depending on what you are going to grow. If you're going to grow something that needs high humidity, orchids, you're going to need fog. Because think about what the humidity is in the summertime in Oklahoma. Sometimes we have high humidity, but more typical is that crystal clear blue summer sky with a humidity about 30%. So inside the greenhouse, you're going to be down probably 25%. And then in the winter, gorgeous clear crystal blue skies in the wintertime, the humidity might be 35% outside, but that's at maybe 35 degrees. And you warm that air up. That's why we call it relative humidity. As air warms, it has greater capacity to hold water, so that humidity plummets. And you could be down in the teens inside the greenhouse, way, way too low. So I tried it without, very quickly learned no, I needed fog. And I tried the fog on our municipal water and very quickly learned, it's not pure enough. There were white water deposits all over the plants, all over the glass, a mess. So this is supplied with reverse osmosis water to the foggers, and that way I don't have to deal with that.
I even see it on the top of my soil sometimes when I have it.
Yes, yes, absolutely. All right. Environmental controls to make sure that the right equipment is coming on at the right time to be the most efficient, because that's the goal, is you want to have the least equipment running that's necessary to maintain those design parameters. So I've got 2 Link 4 iGrow 1800 greenhouse controllers, a wired weather station that picks up outdoor temperature, outdoor humidity, outdoor light, wind speed, wind direction, and is it raining or not raining. So those are the 6 things it looks for. And then there's LinkCon 1800 software that runs on a Windows PC, and that relays any alarms via text message and email to me, so that if I'm away from home or even at home, I know we got a problem and I can go correct it. And it's all accessible via the internet, so I can make adjustments if I needed to and I weren't at home. So the question you're all probably thinking, all right, how energy efficient is this really? All right, let's take a look. So warm house heating stress test. How many of you remember February of 2021? Oh my goodness. 11 consecutive days below freezing, 3 nights below zero in February of 2021. It was bitter cold. So here we are, February 16 at 7:13 a.m. It was minus 10 degrees outside. Ooh, and looky there, 59.9 degrees in the warm house. So I'll call that 60. I think that's fantastic. Look at there, that's almost 70 degrees of lift. That's a huge amount. And that was from the geothermal hydronic radiant floor. And I put the space heater in when I went to bed because I didn't want to be awakened with an alarm. And so, bingo. This shows you when the heat is on. That's the red line. So on, off, where in daytime it was off. Didn't need any heat in the day. Sun took care of that. Back on that night, and the following night, so forth. So that's what those symbols are. The green at the top is your inside temperature. The blue one at the bottom is the outside temperature. The next day, the 17th, it was just under 11 degrees outside, and the system rebalanced at 63.7, so about 53 degrees of lift, and that was geothermal all by itself. So I had designed it for a 15-degree night. It was fine at 11, and I learned this year it's fine at 0. So that's really good. And then on the 18th, it was 5.8 outside, 60 degrees inside, and geothermal all by itself. So the heat was on all night in it, but it was off all day long. Now, that's the warm house. What do you think about the cool house? Same thing going on, minus 10 on the 16th, 43.9. We'll call that 44 degrees. It's set for 45. That's perfect. Geothermal hydronic was on only 4.5 hours. So you can see it over here. On, off, 4.5 hours total. The next night, the 17th, just under 11 degrees outside, 47.5 degrees inside, never came on. No heat. 18th, 5.8 outside, 44 inside. Hydronic radiant floor was only on 3 hours total. Question?
So, I didn't look at this photos, but you have zones on your thermal form?
So, yes, so the warm house is separated from the cool house by that glass wall with a door. And so the warm house is controlled by one of the iGrows, and the cool house is controlled by the other one, so it can maintain 2 different temperatures. And then the floor, the valves are opened, either for the warm house or the cool house, based on when the system, the iGrow, calls for heat. Mm-hmm.
Are they 2 separate floors?
Right, they're a separate set of valves. Yeah. So that way I can control the 2 floors separately.
Off one circulated unit?
So one circulated unit.
Or are they completely separated, like 2 different units?
In the concrete, yes. So the tubing in the concrete floor in the cool house is totally separate from the tubing in the concrete floor of the warm house.
But there's only one fluid loop toll.
Yes, that's why I was like, I wasn't sure where your question was going. So there's one pump, for example, that is moving the water out to the greenhouses. And then those valves in the greenhouses are either open or closed to determine which floor is going to get heated. Okay? Yeah, great question. All right. Well, now, what about a cooling stress test? Oh my gosh. Here we are, July of 22, 14 consecutive days. There's the Mesonet map to prove it. 14 consecutive triple-digit days up in Payne County where I am in Stillwater. Hot, hot, hot. Let's take a look. So here's the warm house. And evaporative cooling with geothermal assist. So July 19 at 4:21 in the afternoon, it was just under 110 degrees outside. Look at that humidity. That's what we talked about, 23% humidity. High light, 1,309 watts per square meter, so very high light still outside. Just under 89 degrees inside. That's darn good. That's almost 21 degrees of drop. And that was achieved by the evaporative coolers. So in the warm house, there's 2 of them. 2 evaporative coolers, both on high, water flowing. And that works really well when the outdoor humidity is low. And then the geothermal floor, I had it come on for 30 minutes and back off for 30 minutes, just to remove some of that excess heat so that when we slipped into night, it would be able to cool down a little better. So by doing that, it doesn't chill it, so I get no condensation on it, but it does just strip away some of that excess heat. So clearly achieved system design there on that. And the cool house. Woo! That's a tough one when it's 110 outside. So same outside parameters, 86.5 inside. That's a lot warmer than that cool house plants really want to be. But still, we're doing really well. That's almost 23 degrees of drop. To do that, I have the evaporative cooler on low with the water running, and then the geothermal 2.5 fan coil is on, pushing chilled air into that space. And the reason I put the cooler on low is so it's not simply blowing that cool air out, but it helps assist with it. And then the floor was completely on to chill that floor and help remove that heat. So it achieved system design, but those plants were not happy. They really wanted to be cooler. But here's what I can do, and here's what's so important with cool growing orchids. They will tolerate a few hot days if you can get them back down cool at night. So at night, the greenhouse automatically goes into active cooling. And so the vents all close, and it uses just that fan coil. And so this is overnight, and on humid days, it's just the geothermal fan coil and the chilled floor. And you could see then these, here's your green is the inside temperature. So let's look at the first hot night. There it is. It was 80 degrees outside. That was the coolest it got overnight. And it was about 62 to 63 degrees at night in the cool house. The next night, we were just barely under 80, maybe about 79, and we were just under 60 in the cool house. And that's what's most important, is get that temperature back down at night. Okay. Any questions on that?
All this ran from your solar panels?
And so that was a more recent installation. We did put the solar array in just about a year ago. And so, yeah, there's 24 kilowatts of solar production. And so much of our home and greenhouse on a gorgeous sunny day, all of it's running off solar. And we're actually putting energy back out to the grid. And then at night, we're, of course, pulling from the grid. All right, well, let's recap. Be inspired. Study greenhouse and conservatory design. Design for your location. Know your design parameters. What's your weather like? What plants you're going to grow? What do they need? Be sure and orient the greenhouse for maximum sunlight. Minimize any shade from trees or other structures. Choose the most energy-conserving materials you can afford. Choose most energy-efficient heating and cooling systems that you can afford. Use environmental control to reduce that energy demand, and seek more information. And so here's a list of some U.S. manufacturers of hobby and estate-sized greenhouses. And these, this list is on the Oklahoma Orchid Society website. So you can go out to our website. It's okorchidsociety.org. And under resources, click and it drops down greenhouse design and construction. At the top of the page, you'll see some of the fact sheets from Oklahoma State University on greenhouse design. And then down here at the bottom are links to those U.S. greenhouse manufacturers that produce hobby size or estate size greenhouses. If you're looking at commercial, there's some commercial producers in the U.S. as well. Question?
So for a starter greenhouse, are you a Costco member?
I am not.
Okay. All right.
So the question was, I'm a Costco member. No.
Well, yeah, they have one display
think about size. Two things. It's never going to be big enough. Your collection will grow and grow, and you go, oh, why didn't I build bigger? And the other thing, the smaller the house, the more difficult to maintain the temperature and humidity. Because it's going to heat up very fast, and it's going to chill down very fast in the winter. Yes?
Is it possible to have modular construction?
I'm sorry, I didn't catch the question.
Is it possible to have modular construction?
Modular construction. You know, you probably could. The biggest challenge with a modular construction is just planning ahead for that foundation piece. Because when you're pouring foundation, and if you've got water lines or hydronic heating lines or whatever, you've got to make sure that you plan a way then to connect onto that should you desire to add another module. Great question. Yes, Neil.
You know, in your experience, right, you went 12 by 60.
12 by 60.
What is a size volumetric or square footage that you think is a maintainable size? You know, what you kind of to the question you just answered.
Mm-hmm.
Okay, well, how big? 12 by 20, 12 by 30, you know, 12 by 12?
Yeah, 12 by 12. Think back to that 1975 greenhouse.
Yeah.
It was a 12-foot diameter. It was really small.
Yeah.
And so, yeah, it's nice size, but very quickly you feel cramped, don't have enough space to grow things. And of course it is fairly small, so it's a little more challenging to maintain the environment. I would say probably a 12 by 20, 12 by 24 would, yeah. So a 12 by 24 is essentially the cool house.
That's your cool.
And the warm house is 12 by 36. Yeah. But so I think, probably a 12 by 24 would be a good starter size, but you're going to wish you had bigger. Yes.
How much of your floor space is taken up for like the workbench area?
So the benches in the greenhouse specifically are all for growing plants, and then the room of our home to which the greenhouse attaches is what's called a head house, and that's where all the potting's done. So that's where I have the stainless steel benches that I can sanitize for potting up orchids, all the pots, the various potting media that I need for doing that, all that I do in the head house. That's where the environmental controls are housed, and then carts can take stuff right out into the greenhouse. Great question. Yes?
You ever have like an open house to let people come and look?
Yes, we've hosted the Payne County Master Gardeners, and last May we hosted the Oklahoma Orchid Society and Kansas Orchid Society. Yeah. Any other questions?
I got a question just about plants.
All right.